In this video, we'll just touch on the notion of critical values. For a normal distribution, a critical value is a z-score on the borderline, separating the z-scores that are likely to occur from those that are unlikely to occur. And our notation for this is z with the subscript alpha. So we'll refer to these more later. That's why we're just starting this discussion here. But let me take this a little further with this z sub alpha. This denotes the z-score with an area of alpha to its right. So this is a z-score, score. Thinking too fast here. This is a z-score with an area of alpha. Alpha just stands for the amount of area to its right. Okay, that's a little different than what we were doing with the inverse norm area to the left. So now we have to keep in mind this is area to the right. So whatever the z-score is, it has that amount of area to its right. So let's just do a quick example to get an idea of this. We want to find z sub alpha, where alpha equals 0.025, or 2.5%, and changing that to a percent. So it would be written z 0.025. What z-score has an area of 0.025 to its right? Okay, so let's get a diagram of this. So we know that 50% is to the right of the mean. So we're talking way out here where to the right this area is 0.025. Okay, so the question is, what is this z-score that has an area of 0.25 to its right? Well, now you should be thinking you know how to do this, right? We use the inverse norm. Inverse norm, but recall it requires area to the left, and this time I've just labeled it z instead of a as I did before, so I'll just say to the left of z. Okay, so the area to the left, if that's 0.25, I can write inverse norm, and you can actually enter it this way if you're careful in your calculator. What would the area, how would we find this area to the left? We would take 1, which is the total area under the curve, and subtract off that 0.025. You can actually enter that in your calculator. Those of you that your calculator inverse norm function is like this, and a little different than the one that I have, that I'm showing you here. So in other words, that area is going to be 0.975. Okay, so let me pull up my calculator, and again we're going to our distribution list. These are our distributions. Go to inverse norm, and I'm going to put in 0.975, or if yours just pulls up a parentheses inverse norm and it's ready for you to enter the area, you can enter this. Okay, enter, enter, enter. Okay, 0.975, and I get 1.95996. 1.95996. Okay, again with z-scores we round to 2 decimal places usually, and so this would be a 1.96. Now recall, this is about critical values. So there are certain z-scores that are considered critical values because they separate, they're at the borderline of z-scores that are likely to occur and those that are unlikely to occur. And just to start that thought process, if we're using a probability of 5%, anything less than 5%, we've said less than or equal to 5% was unusual. If we take that 5% and split it into two areas, right, at the top, that would be 2.5% at the top, 2.5% at the bottom. Okay, so that would be separating out those values that are either below or above in the unusual range. So we're starting to find z-scores that we'll be calling our critical values. We'll talk about this some more later.